Hi, I'm Ismail. So I will show you tonight how to write code, for the nuclear air 401 for the simple problem which we have discussed in the class, right? We discussed how to toggle the LED, right, at 2000 milliseconds interval continuously, while pressing the push button, then we toggle the LED. All right, so we have so how uh, if you see here through the flowchart here, we can see that, right? So we toggle the LED, then delay for 2000 milliseconds. Then after that, capture the button, the pressing of the button. So if the button is pressed, which is because we are using the active low push buttons, that means that previously 1 and now it's 0, then the LED will be toggled to, right? However, since the controller spends nearly 29.99%, we can say that about it, right? If you uh, use, say, the clock, right? Clock about it, say 40 meg, 40 megahertz. So it spend about 40 million, 40 million times, to to be busy with time delay. Then only one time, then it will read the button. Right? So it is impossible for us to for the controller to capture it. Therefore, we need to change the code or the sequence of the code, right, by introducing a time delay. Then use the loop, LO here mean refer to the what variables called loops, right? Loop 0, for example. And then we increase that loop until the loop greater than the repetition that we want. So if the time delay is 10 milliseconds, I mean that the loop uh, repetition is 200 times, right? 200 times. And then if the loop greater than the repeat, say 200 times, then we uh, re resets the LO to 0, the loop to 0, and then toggle the LED. Therefore, equally, we can provide a time for the processor, right, to read the push button and to toggle the LED, right? So here, through the part chart, he said that the code has been modified to address this issue as shown in the second flow chart. The new approach implement account loops with repeat conditions, reducing the delay and increasing the likelihood of detecting button presses while maintaining the LED toggling functionality. So this is what we this what we uh, have done in the previous classes, right? So next, the same problem that we have here also can be solved by using the extended interrupt. I mean that the main loops just spend time here for the time delay and so on. So whenever it is interrupted because of the extended interrupt is higher priority compared to the normal code, we can say the normal code in the main, then it will be executed, right? It will be executed. So this is a solutions of this using the interrupt, right? Another way that we can use is using the SysTick, right? The SysTick, or sometimes we call SysTick Timer, right? The SysTicks. So this is due to the delay that we introduce here, right? It is okay for normal, simple applications, right? But in real-time applications, it can be detrimental as they waste processing time and block other important tasks from executing. That means that whenever we use this one, right, right, when we use the delay here, this is sometimes we can say that dangerous to the code, to the system. Therefore, we don't want to use that delay. Actually, when we use a delay, actually the processor intact to the internal processing, which is maybe wasting time. right? By reducing maybe the variables, the value of the variables, right? So it's still doing something actually. But whenever we use the SysTick, it is the processor time uh, can be used for others, because it's not it use no time for that processing, right? Here we can see here, say, assume that we have, if this is executed at say 10 say 1 millisecond for simple, this is 1 milliseconds uh, execution is executing at 1 millisecond. It means that the processing time is 10 milliseconds, and then this time out say at 10 milliseconds. So only 1 or 10% of the time used by the processor, while that 90% still available for others applications, right? um, Basically you can read from my notes, note 3b, when I'm talking about the SysTick. Actually the SysTick is the mandatory timer built in all ARM processors, right? uh, Each provides a more efficient and non-blocking way to handle time-based events, allow precise time management without halting program execution, and allowing the processor to continue performing other tasks while keeping track of time. It means that while it is the timeout, it's not time out, not elapsed, right? So that time, as I told you before, it is about 90%. We can use for others processing or for other tasks, right? All right, now I show you how to write code by using the SysTick. I show you the simple the basic way, and then I will show you the way I use the driver that I've designed for the SysTick. All right. Okay, so create the project first. See here, we create set the button, right? I don't care about the clock. The clock is 16 megahertz because this is just a simple applications. Right? Just ensure that PC13, which is handle the push button, right? Push button already set, right, as the input, right, as the input, and then you can better you name it, better you name it. Enter the user label or label it to button, and then when you see the GPIO, right, then no need for us to set the right the pull up and pull down, right, because externally the push button already pull up, and remember the button is active low, right? The button is active low. The second thing is go to the PA5 and create it as GPIO output. Then you can label it, right? Label it to LED. Then ensure that it is set to output push pull, right? No, and then no pull up and no pull down. Okay, then create the project. Generate code. Right? You create the code, then you will have the main code like this, right? If you don't have the main code, no problem. Just go to the core. Sorry. Okay, go to the core. Then you can click in the source, find out main, double click to open it. Right. So now we in the main code, right? Control Shift plus to increase it. All right. So first thing first. First thing first, we're going to write code here. Okay, before that, we need to switch off, for example, if you want, right? So during the initializations, we need to off the LED, right? For example. So you can type HAL underscore GPIO underscore reset. Oh, sorry, reset, right? Sorry, right LED, type LED, control space, LED GPIO port, okay? And then LED pin, control space to find out LED pin. Then the pin state is GPIO underscore pin underscore reset, right? Because the LED is active low. Alright, next, because we're going to use a SysTick, and the SysTick is 24-bit, right? 24-bit, so we need to define, to declare UINT 32, right? See, I name it as TO out, right? Time out. Okay, we're going to use it, right? And then go to the, we need to initialize it, or it's look like to set, right? If I told you in the class, it's look like to set the time, right? Once you enter the processor into the main functions, you need to know the internal clock. What is the present internal clock? Just like you go to Japan, for example. So when you touch down at Narita Airport, then you need to set your time to the Japan's time. All right. So you type it. So just TO control space is equal to SAL_GAT double tick. Also okay. GAT tick. Right. Get the time first. Right. Okay. All right. So in the code, you can write down like, now I just replace it. I just replace it here. So here it's look like we have the the if, right? If actually if I take this one out down, right? Down, you can see that it's look like if timeout do this, else just skip it. So just keep it and then turn back into the top of the timeout, right? Okay. So it's so we can redraw it like this. Okay. So we can type it here if, right, T node is less than the HAL underscore get tick, right? Get tick. So then it is become yes, right? Okay, yes it. Right? No, you just skip it. Just skip it. Alright. Okay, then we need to copy it, right? Okay, this just looks it's look like, see, your time, that time is 10 o'clock in the morning. Then you have a function in 3 hours later, right? 3 hours later. So you can set it to tick out, right? You just reset the time to equal to SAL_get tick, right? Plus with, right? If 10 in our case is 10 milliseconds, so another 10 milliseconds, then it will again time out, right? So this means that each 10 millisecond, the if statement become true, right? The statement become true, right? So then we write down the code, right? The code here. It looks like another user code for us, right? User code here that do whatever that we want, based on that timeout. So what we would want to do is, first thing first, we increase the loop, right? We increase the loop. So here, before that, you can write down that loop, right? Set it equal to 0, right? Loop to 0. So you copy this one, right, and place it here. Remember, variables, if it is possible, you put it at the lower level, right? Put it at the lower level. And then I choose to use UINT 8_t because later, right, I will, right, the repetition is if plus loop, right, greater than 200. That means that our loop is and the value for or range of loop is from, and then we will reset the loop to 0. right? So it means that our loop is from 0 up to the maximum of 201. So this range can be covered by UINT 8. And that's the reason why I use UINT 8. Then toggle the LED, HAL underscore GPIO underscore toggle T. Toggle it, control space, oh sorry, okay, control set, okay, okay, just control space, type LED, right, control space, then you got the port, then type LED, control space, you got the pin, semicolon. So that's all for this, and you settle it. Okay. See here, we increase the loop, then if the loop greater than repetition is 200, because 200 multiplied with 10, then it will produce 200 milliseconds. That means that this loop is only true when it is each 2000 milliseconds, each 2000 milliseconds. Okay, then for the next, which is our our buttons here. So as usual, what we do for our buttons, the button is active low, active low. So it means that when you press, it becomes 0. The previous 10 minutes before, that hold that what determine the status of the button. If previous 1, now it is 1, that means you not press it. If previous 1, now 0, that means that you press it. If previous 0 and then now 0, it is not pressed. Sorry, it's still press or holds. If previous 0, now it is 1, then you what you depress the button, or release the button. Okay, so what we can do is, first we could sample the previous one, which is hold by SW node, right? Then SW node must be updated, right, by reading the button, the status of the button, GPIO underscore read, go to space. So this is button, BUTT, go to space, you got button GPIO port there. Then type another button, go to space, then you got pin. Read the pin. Okay? You read the pin. Then from here, what you do is to check the previous and the present. So if, right, okay, before that, okay, because we use switch 1 and switch 0 in the main, so better we place it here. So I will use bool, bool, and place it. Right, so we have switch 1 and then we have switch 0. But this is a tips. Previously, when you start it, SW node must be not pressed. So it must be GPIO underscore pin underscore set. It must be at 1. Okay, now we use pool. Go to top here in the include pound INC. Then type std bool. Right, set the bool. So now the bool, for this we already include the preprocessor, the preprocessor for bool or boolean. So if SW control space SW1 is equal to GPIO underscore pin underscore set. Previously it is high and now the present SW node is equal to GPIO underscore pin underscore reset. Right, so the button is press. Right, the button is press. So what you do, toggle the button. Toggle the button. So that's all the code. Right, that's all the code. So you can see here, I did already the code for this one and for this two. right? So we have if inside if, right? We have if for this, and then another if here, right? And if, right, the inner the outer if that handled by the timeout. So we have if here, the first one, they handle the timeout. Each 10 millisecond it will come through, and then the if here, when the loop greater than 200, then it become true, and then the if here, if the previous if the button just being pressed, and then what you can do is, right, compile it, right? So you can compile it. It takes some time. Okay. Okay. I'm going to download it. All right. Now I run it. Click here. Run. So I'm going to download it. Straight away, download it. So you can see that yeah, it is downloaded now. Right, it's downloaded. And now you see the LED, right? The LEDs will be off at first and then toggling at 200 milliseconds. See? Now if I press a button, then it also will be toggled, right? And it's the same time, then it will toggle by that loop, right? 200 milliseconds. So complete it, right? Complete it by using the SysTick. Now, what you can do is, right? Okay, I take all this out first, right? Okay. So okay, for the last time I will show you the code. Okay, first on top here you have the the bool, standard bool. Second one you have t out here, and you declare it as uint 32 underscore t. Then here user code begin, we have three variables: loop, sw1, sw0, that set to low or GPIO pin underscore set, right? That is just a tricks for you. Then we off the LED, right? Then reset the loop to 0. Then set the time out to half get tick or the present. This one set t out to present to present SysTick. Then here we check if the t out less than half get tick. Remember, half get tick is internally increase, right? Increase in the HAL programming. It's automatically being set. No need for you to set the SysTick, right? Not just like in the bare metal. And then if we time out, then we check the LED, sorry, the loop. If the loop out, that means for 200 milliseconds, where we get it, 2000 milliseconds, where we got it, 200 multiplied by 10, so it becomes 2000 milliseconds. Then we toggle the LED. Then we check the push button. If previously it's not pressed, now it's being pressed only, then we will toggle the LED. Okay, so I take out these all codes, right? Delete it. I will delete this one too, because I want to start again using the user tick, the user tick, the driver, right? Please get it from where? From okay, Okay, so you go to the notes. Remember to download. Oh, sorry. Okay, to download this. Data sheets, coding class, video. Oh, sorry. Wait. Okay, software. Here you got the software driver. Software driver. Okay, inside it. Okay. So get the one from the new one. The new one. SysTick. Wait, SysTick driver. SysTick new one. Okay. Got from here. Right. We have SysTick C and SysTick H. Alright. Now I'll show you the code. Once you download it, place the code here in the driver. Okay. So you have the SysTick, right? That I place the driver inside my my STM-F01RE. I open it. Okay. So you got SysTick here. Okay, now minimize the code. And then so you can see here the include underscore include and source. So what you do, the C one and the C file one, left click on it and then control, right? Control, press control and then move it to the your source. Okay, and then accept to copy it. Right? If you not press control, then it will go, right? So you have SysTick in source, then go to SysTick.h. Again, press control, then place it inside include and then accept to copy. So you have the code here already. Right? You have the code here. SysTick.h. Right? This is code. So what's that? Microcontroller. What's the problem? Okay, no problem. Just forget it, nothing. Okay, go to the main. Then go to the user code begin include, right? Pound INC include the double quote. Now, previously you use the left and right sign, right? Okay. Now we use a double quote because this is user driver, user preprocessor, right? Or code. Then you include it by type in user USE, for example, control space. Then you got the SysTick.h here, right? Then inside here we have a lot of things here. Okay, the first one that we have, okay, number of tick to be used in this program. If you want to use more than 5, for example, you need to change it, right? This one is by default. I put it to 5. Okay, so you can use tick 0, tick 1, tick up to tick 4. And then this is init tick timers. Okay, if you want to use the timer, you need to init it first, right? Just like we previously we set the T out. The T out we set it to the HAL get tick. Okay, but now we can use these functions, right? You just write down, right? Okay, how many tick that you want. Okay, you can write code either by maybe. Okay, so first here, what we're going to do is to what? Sorry. Okay, to off the LED. So we type HAL underscore GPIO underscore right. Oh no, professor. Why no, professor? Oh, sorry, I'm not there. Here should be good. The initialize, right? HAL underscore GPIO underscore right. Write it. LED, go to space, GPIO port. Okay. Then GPIO LED, sorry. LED pin. Then type GPIO underscore pin underscore reset. Remember, the LED is active high. Okay. Then we're going to use loop. Type in loop equals 0. Right. Then we're going to init. You can write down a simple one. Just type init init tick timers num1 because you're going to use 1. Or you can write down, let's say, while open bracket, because this init timer, it will return returns 0 or 1. Okay, you can make use of it. Return 1 means it's okay. Return 0 means it's not okay. So while not, maybe you can write down like that, not init tick timer. So you put 1 here. It means that it will stop the code. This one, it means it will stop the code when your init tick timer return 0. When it's return 0? When it is not okay. Okay, when it's not okay. So when it's not okay? When, see, when the tick value that you supply here, or number is greater than the number of tick. The number of ticks here is 5. Say you write down 6, and then you will return 0. Okay, but if you know, no need to know the maximum tick timers, you handle it, so no need for you to use this. Okay, and then that's all for that init. You need to init it. Then copy this one just like before. Copy it and place it here. As I told you that I'm going to use UNT8 because of the range of that loop is from 0 up to 1. That can be handled by UNT8_T. Control V. Right. Then we have it already. Sure. Then here we can write down if get no, sorry, go to user tick. Okay, you check and update the tick timeout. Okay, so this one will return 0 or 1, 0 or 1 or negative 1, negative 1, that one. So if not valid number, valid number means if you have, say, you set 0, 1, 2, right, 3, then you ask for tick 4, then it will return you negative 1, because that number you not set it before you use. Then return 1 if timeout, return 0 if not timeout. Okay, so you can write down here, check, check, go to space, check and update the timeout that we use only 1, then so number 0. Remember, binary start from 0. Okay, then timeout, then you can write down 10 for our case because of 10 milliseconds, right? That's all. And then you can write down code for if, code for the let, right? Plus loop, right? Loop greater than 200. Then what you do? Then you need to HAL underscore, first, make it become habit. First of all, you must set the loop first to 0 again. Reset it. Then what you do? Then we toggle the GPIO underscore T toggle. The LED into space port, LED into space the pin. That's all. Settle for it. Next, we go for the button. Okay. So we have the output and then we have the input, and we need to check the input. So the input is SW1. Again, I use the same technique. Copy the previous first, which is held by the SW node. Then SW node must be updated with the new value or status of button. Okay, how GPIO underscore read. Right, read from GPIO. Here is button. You can type button. Remember, I showed you last time. You can type what's the GPIO port C, GPIO C, GPIO pin 13. You can write down like that, right? but you can also write down something like this by using the introduce the label to the pin, and then let pin, sorry, not let, button, button pin, button control pin, semicolon, right? Then from here we check if SW1 if SW1 is equal, right, is equal to GPIO underscore pin underscore set, previously not pressed, and now SW0 is equal to GPIO underscore pin underscore set, reset, press. Then what we do? So we toggle the pin. We toggle the LED. Right. So this is code. Okay. Okay. So here you see, I already introduced SysTick, and when I use bool here, bool. Oh no, sorry, I declare the pin. The reason why we declare after we use it, because of when you compile it, I show you when I compile it. Okay. You can see here later. When you compile it, okay, you see here, it will let us know that SW0, SW1 is not declared, right? So if you can remember it, why not you declare it before you compile it? But the reason why we compile it, we declare after use because of we don't want to declare a lot of variables, then we not use it. Okay, enter, type bool, and then place it there. Again, we have SW1, 2 variables, and then SW0 that we declare, and then we also define it, right? Define it or initialize it to high or set, right? Because by nature the button should be at high, right? So if you not set it to 0 or to set it to the status, to the correct status, so you got a problem here later on. Okay, I see one problem here. Okay, right. So you see here another way, rather than you can go here to check what's the problem that you have, and also look at the code. When you look at the code here, you see this one, you got line, the red line, right, at the bottom of that character, right? So it means that we have some error here, so we need to fix the error, right? Okay, and the reason why I not define the bool here, because if you look at, okay, just control and then move your mouse here, click, then it will open up your SysTick.h. So here you can see that I already include standard IO, string, standard bool, standard library, standard int, integer, int type, and so on top of the header file here, right? Header file. So when I include it, it means that it looks like I already also include all this, all this being included here. Okay, remember one thing: if you not use the SysTick in your main, maybe you use in other file of your main, then you need to only include that SysTick inside that file, not always in the main. Okay, next, after that, run it, click OK. Okay, hopefully we have no problem, right? Okay, now I download it, then you can see the status here. Okay, zero error, zero warning. Okay, if we got error, then we stop us. If you run it directly, and then it will start download. You see this? Okay, that color blinking, right? That LED, the LED blinking, LD1. And then you see when after that, then we'll off the LED for 200 milliseconds and then toggling it right at 2000 milliseconds. Sorry, 2000 milliseconds. Then you press the blue button. Okay, so later on we will use this user tick, so study it. Okay, and I will show you some of others ready-made functions here. For example, we have the tick timeout. Okay, actually you can read it later. You can read it, right? Or set tick timeout, right? Set tick timeout. Okay, and then start tick timer. This one you can start tick timer. Which number if you want to pause it to start. Okay, and then if check check elapsed time. This one we use in the functions for debounce to solve the debounce. This one. So I will show you this one once we again revisit the what we call revisit the interrupt, right? Interrupt. What's the problem with interrupt? Or what's the problem that we have with the key debounce? Okay, now I already download it. Now we go to the what, and then look at this, right? Okay, it's toggle. Now I press button. Right, each time I press button, then it will toggle. Right, it will toggle, and then you see it is toggling at 2000 milliseconds. That's all. Okay, so I show you last for the code here. Main. On top of the main, right? First, we need to, okay, before that, we go to the program project explorer. You need to include both, right? Header file and also the header file and also the source file. Source file goes here inside the src or source code, and then include .h should be here. Right? So you study how to include the user file to the project, and then you go to the file that you want to include the file or user ticks. For example, here we're going to include it into main because we're going to use the functions inside that user tick and our main function and main file. Then you go here inside the user code begin one. We have three variables, which is sw1 for the main hold the value of the previous button press or status of the buttons. sw0 that we hold the value of the present as status of the buttons, and then we have a loop. The loop. Please insert this loop. The variables type. The type of variables that we use here. What type of loop? Must be uint 8_t in this case. There's the most suitable one. The most suitable one, because again, loop is from 0 up to 201. Remember, so it is in the range of uint 8_t, which is from 0 up to 255. You can calculate it by looking at the chapter 2b, right? Chapter slide 2b, as discussed it. Next, we go to the user code begin 2. So the first one we off the LED. The second one we reset or initialize the loop to 0. That means we start. We start, and then in it take timers because we use only one. That's become 1. Then in the code, then we use the function check and update tick timeout. Right. So this one means the tick that we use, the number of tick. Right. The tick number is 0 because we use 1, right? Then the second number here means that each 10 millisecond. So each 10 millisecond, this one become true. Then after that, then we check the loops. If the loop is 200, 200, that means it's already 200 millisecond by multiply 2000 millisecond by multiply 200 with 10 milliseconds, so 2000 milliseconds. So reset again the loop to 0 and then toggle the LED. Then copy the previous button status to SW1. Then get the present button status into SW node. Then compare. A previous button is not pressed. Now it is being pressed. Remember, this button is active low. Then we toggle the LED. That's all. Bye bye. Assalamualaikum.